All right, pre-calc, on today's notes, we are going to put everything that we've been learning together into one problem. All right, we're going to do two examples of it, but we're going to be putting together the amplitude, the period, the vertical shift, and the phase shift all into the sine function. So let's first of all start by reviewing the 446 notes with graphing just a phase shift. So we have a plus 3 pi. So, of course, that means we're going to be doing the opposite and subtracting 3 pi from all of our x values. So let's start off with our parent function, like we've been doing. I don't like that y-axis. Let's start this over. All right, so start off with our parent function here. So, again, 1, -1, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Oh, that line's too long. That's all right. All right, so we're going to start off with f of theta is equal to sine theta. Oops. There we go. So we got our point at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0. Again, we've been doing this a bunch of times. You've probably seen this close to 15 times now, I would say. If you've been watching all the notes, that is. All right, so plus 3 pi, like I said, we're going to take all of the x coordinates and do the opposite and subtract pi. So I'm going to make my list. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to do minus 3 pi. So 0 minus 3 pi is -3 pi. All right. Again, I should have, before I started that, just draw my x-axis and put my 5 points. So 1, 2, 3, 4, 5. And again, I'm going to fill in the y-axis later, where whenever I figure out where 0 is. But the first point, 0, was shifted over to -3 pi. So my first point is going to be -3 pi. Next up, we got pi over 2. So we're going to do pi over 2 minus 3 pi. Okay, and again, remember, if you're not doing okay with these, just use your calculator. Just do 1/2 minus 3. And, you know, depending on how your calculator gives you the answer, it may give it to you as a decimal, like -2.5. But we want to change that to -5 pi over 2. So there's our next point at -5 pi over 2. Next up, we have pi minus 3 pi. Again, treat that like it's an x. So x minus 3x would be a -2x or -2 pi in this case. So -2 pi. Next up, we got 3 pi over 2 minus 3 pi. All right, 3 pi over 2 minus 3 pi. So 3, again, on your calculator, if you do 3 over 2, we're going to do 3 over 2 minus 3. That's the same thing as like 6 over 2. All right, so 3 over 2 minus 6 over 2 is going to give you a -3 over 2, or -1.5 or whatever. So -3 pi over 2. That's our next one here, -3 pi over 2. And then the last one, 2 pi minus 3 pi, well, that's going to just give us a -pi. All right, so -pi. All right, so now after doing all that, I know that my y-axis will be over here somewhere. All right, so again, on the 446 notes, we did not do any of the moving around in the y-axis, so we're still -1 to 1. We're going to write our function up here. So f of theta is equal to sine of theta plus 3 pi. All right, so first up, our first point, 0, was shifted over to -3 pi. So 0, 0 is now -3 pi, 0. Up next, pi over 2. Well, pi over 2 was shifted over to -5 pi over 2, so that's going to be -5 pi over 2, 1. I'm sorry, pi over, pi was moved over to negative 2 pi, so that's at 0, right? We had pi 0 right here. That got moved over to negative 2 pi 0. Next up, 3 pi over 2, negative 1 was shifted over to negative 3 pi over 2, negative 1. And the last one, 2 pi, was shifted over to negative pi, so that's at 0. So this is what our final graph would look like here for sine of theta plus 3 pi. All right, now in your notes for today, what I did was I just kind of made a list of all the things that we're going to do here. I also finally put down an actual graph here so we can see, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. That is the parent function for sine theta. And we're going to use that as our parent function and then shift it around here for all these other steps. So what I'm going to do is I'm just going to color code everything. That's my first step. So not my first step, but my first graph. My first step, I'm going to do this one in green. So remember, the amplitude is the absolute value of your first number out here, which in this case is a negative 1. So the absolute value of negative 1 is just 1. All right, then I'm going to do the period. The period I will do in blue. So remember, to find the period, we do 2 pi divided by the absolute value of b, which in this case is 2. So 2 pi, hopefully you can fit that in there a little better. Actually, let me take a step back here. I want to try and do this in a smaller, a thinner line, sorry. 2 pi divided by absolute value of b, which b in this case is 2. So the absolute value of 2 is just 2. So we just end up with pi. And remember, for period, we're going to take all of those x coordinates, 0, pi over 2, pi, 3 pi over 2, and 2 pi, and we're going to divide that by 2 or multiply by 1/2. All right, so we'll do that in that step. The vertical shift, in this case, the vertical shift is plus 3. So we're going to move that graph up 3 units. So you can also make a little note there of that. That's going to go up 3 units. And the purple graph will be my phase shift, which the phase shift is the minus pi. So phase shift, we will actually be adding pi. That's a plus sign. We'll be adding pi to all the x coordinates, okay? So we're going to do these one at a time. So let's just go ahead and jump right into it. First up with the amplitude. So I'll do these, we'll do these in order. So this will be my first, second. I put them in this order for a reason, because that's the order that I'm going to graph them in. So let's just start it off here. So amplitude, the amplitude is still 1. So the height of the graph will still be 1 to negative 1. But because there's a negative here, it's going to flip it. All right, so let's start off by graphing that. So we're still doing 1 to negative 1. My x coordinates are still the same, pi over 2, pi, 3 pi over 2. Sorry, my handwriting is getting a little sloppy here. And 2 pi. So again, this one I'm going to do in green. So let me put the graph, or the function f of theta is equal to negative sine theta. Now the negative just means there's a flip. If there was a number in here other than 1, like a 2, 3, 4, 5, whatever, that would stretch it out. Or if it was a fraction like 1/2 or 2/3 or something, that would squish it down. But since there's just a 1 there, it's not going to stretch it or squish it at all. The negative is just going to flip it. So we're going to take all of these y values and we're going to multiply by negative 1. Okay, so I'm going to start with this, 0, 0. Well, 0 times anything is 0, so that's still at 0. But then my next point, pi over 2, was at 1. Multiply by negative 1, and now it is down here. So pi over 2 is at negative 1. Up next, we have pi. Well, that's at 0, so multiply by negative 1. We still got 0. 3 pi over 2 is at negative 1. Multiply by negative 1. That puts us up at positive 1. And we always have to end where we began. But if we look at 2 pi is at 0, 0 times negative 1 is 0. So all that happened here, it wasn't stretched or contracted at all. It just flipped it over the x-axis to give us that graph. All right, now I'm going to move up here. I still want to leave period on the screen so we can see what's happening. So we're going to take all of these x coordinates. All right, we're going to take all of the x coordinates and either divide by 2 or multiply by 1/2. It's the same thing. So if I start out with 0, we have 0 either, like I said, either divided by 2. I'm going to multiply all these by 1/2 because I think it's easier to see it that way. Of course, the first one is just 0, so that doesn't really do anything. But if we do pi over 2, let me just show you real quick. If we do pi over 2 divided by 2, that's a mess, right? We don't want to do that. That's just messy. It gets confusing. It's much, much simpler to just look at this as multiplying by 1/2. And mathematically, it's the same thing. So let's just make our life a little bit easier, right? These things are challenging enough, so we don't want to make it any more difficult. So pi over 2 times 1/2. Pi times 1 is pi. 2 times 2 is 4, so we get pi over 4. Up next, we have pi. I'm going to multiply that by 1/2 and leave me with pi over 2. All right, that's like pi over 1. Next up is 3 pi over 2. And I'm going to multiply that by 1/2 to leave me with 3 pi over 4. And the last one, 2 pi, we don't have to do that because we already did it right here, so no need to redo that. All right, so let's draw the x-axis here for our new graph. Y coordinates are the same. They're not changing in this graph here. They will change in the next graph, though. But now my x coordinates are starting at 0. The next one is pi over 4. Next is pi over 2. Next is 3 pi over 4. And the last one is right here, and that's pi. All right, so again, remember the period just means how long does it take for this graph to repeat the cycle where it started and up, down, or down, up, whatever, to get back to where we began. So started at 2 pi, but then it was moved over to pi. All right, so this is my blue graph. Let me get my blue pen here. And what do we have? Well, we have f of theta is equal to negative sine of 2, not pi, sorry, 2 theta, not 2 pi. Back up. I was looking at the formula for period when I wrote that. 2 theta. There we go. All right, so 0 was tracked to 0. So that didn't move. 0 is at 0. Next, pi over 2 was moved to pi over 4. So let's look at our previous graph. Where was pi over 2? Well, that was negative 1. So now pi over 4 is at negative 1. Then pi was moved to pi over 2. So pi was at 0 in our last graph right here. So that's it. Pi over 2, 0. Next, 3 pi over 2, 1 got moved to 3 pi over 4, 1. And like I've been saying, we got to end where we began, so that's where we're at. And I missed my dot there, but you can see that this is going to basically look exactly the same. And really the only difference here is the x-coordinates changed. Even though the graph looks the same, the x-coordinates change. And we could see it ended at pi here. So if I were to graph this on the same one, it would go down, back up, and then back here is where it would end. So like the whole graph would fit in here instead of, like this, what we have here. All right, up next I'm going to do the vertical shift. So that is a +3, and this is affecting the y coordinates. In the vertical direction, that's y values going up or down. So +3, if I look at my previous graph, that started at 1, so +3 will bump that up to 4. 0 plus 3 will bump that up to 3, and then -1 plus 3 is going to bump that up to 2. All right, so let's go ahead and put our y-axis down. And I'm going to put my x-axis down here because I know everything is moved up for, 3 units. So my top one is again at 4. And then 0 plus 3 is 3. And -1 plus 3 is 2. All right, so again, I'm doing this red part here, up 3, the +3. That is what I'm doing in this next step. So f of theta, let me write this in here, is equal to -sine of 2 theta, and then I got a +3 on the outside. All right, so x coordinates are not changing here. They changed in the last graph, and they will change in the next graph. Let me move this up. So pi over 4, well, we're starting out at 0. Pi over 4, pi over 2, 3 pi over 4, and the last one is pi. Okay, so let's see where all of these points are now at. So we're adding 3. So this, going back to the previous graph, was at 0. 0 plus 3 is 3. So that one will be right there. Next point was at -1. Well, -1 plus 3 is 2. So that point is right there. The next point was at 0. 0 plus 3 is back at 3. Next up, 3 pi over 4 was at 1, while 1 plus 3 gives me 4. And the last one, pi, was at 0. 0 plus 3 gives me 3. And like I've been saying, each of these steps is pretty straightforward math. You know, adding 3, that's not hard. Multiplying by 1/2, that's not too difficult, especially since you can use a calculator. You know, just remember to leave pi out of it and bring it back in later. So it's not really like each of these steps is not super difficult. It's just a matter of keeping everything straight and remembering what to do. The math itself is pretty simple and straightforward. Okay, so the last step here is your phase shift, and that is a plus pi. And again, that's because in the equation was a minus pi. So we do the opposite and we add pi. So again, you may want to do all of these on your calculator. And this is where it's going to be a little different from the last one because these values are different now. But it's the same process. We're still going to take these x coordinates. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. And what are we doing with them? Well, the phase shift says add pi. Because it's a minus pi, we do the opposite. So we add pi. So we're going to do that to all of these. We're going to do the 0 plus pi, which gives me pi. And again, I forgot. My bad. Let me back up here a second. I forgot. I want to just put my x-axis down. And I want to throw 4. Oops. Let me actually move this. I want to move it down. Since the whole graph was shifted up, I want to move this down a little bit to make sure I'm not going to run into any work up above there. So I'm going to put my 5 points, 1, 2, 3, 4, 5, and I'll fill in the y-axis later. But for now, I know I have 5x points. So my first point, 0, was tracked over to pi. So there we go at pi. Pi over 4 plus pi. Well, this is going to give me 5 pi over 4. Again, you can do that on your calculator. So pause the video if you need to and plug it into your calculator and you'll get that. Pi over 2 plus pi. This will give me 3 pi over 2. So 3 pi over 2. And again, there is a pattern here, and I know I haven't been pointing it out the past couple of times, but this is pi, which is the same thing as 4 pi over 4. And then it's 5 pi over 4. And then 6 pi over 4, which reduces to 3 pi over 2. Then next is going to be 7 pi over 4. And then the last one will be 8 pi over 4, which is, well, you guessed it, 2 pi. All right, so let's just verify that here in our other parts here. So we're going to add pi to this. So 3 pi over 4 plus pi will give us 7 pi over 4, so we're good there. And the last one, pi plus pi, gives us 2 pi. All right, so we did verify that. But again, there will be a pattern. There's always a pattern. It's just some patterns are easier to pick up on than others. Okay, so since my first point is at pi, I know 0 will be over here somewhere. My y values are not changing from the last graph, so that's 4. It's a 3, and it's a 2. So last graph here, I'm doing this one in purple. I'm just going to recopy the whole thing here now. So negative sine 2 parenthesis. The parenthesis is very important right here. This parenthesis is very important. Theta minus pi, parenthesis, 2 parentheses there, plus 3. Final graph. So let's see what happened here. 0 got moved to pi. So this point right here, 0, 3, gets moved to pi 3. Next, pi over 4 gets moved to 5 pi over 4. So pi over 4, 2, right? Pi over 4, 2, gets moved to 5 pi over 4, 2. Next up, pi over 2 gets moved to 3 pi over 2. So pi over 2, 3, pi over 2, 3, gets moved to 3 pi over 2. Sorry, I'm trying to keep this away from the watermark there. 3 pi over 2, 3. 3 pi over 4, 4. So the x value is 3 pi over 4, y value is 4. That gets moved over to 7 pi over 4, comma, 4. So up there. And then 2 pi, well, that came from pi, so pi 3 gets moved to 2 pi 3. So here's our final graph. And again, these don't look super great, but you get the idea. You can see what it's supposed to look like there. So the important part here, again, like with all of these graphs, is you need to make sure your y values are correct. You need to make sure your x values are correct. Definitely need to have them labeled. I would strongly suggest that you're putting the work down so I can see what mistakes are being made, if any. Hopefully none are being made. You know, if you're doing these on your calculator, you'll be all right. But, you know, that's just my way of being able to tell. If all you have is like, if you just have a graph that looks like this, I don't have any clue what's going on there. And especially on your homework, you're not going to get credit for that. So your homework for these problems, you're only going to have 2 problems to do. The reason for that is because I just don't want to give you a bunch of these because I know each step takes a lot of work. Each problem has 4 steps in it. And I don't want to give you like 4 or 5 problems on these because I just don't want it to take you too long. Okay, so you need to make sure you're trying both of the problems. You need to make sure you're showing me work and everything so that you can get credit on them. So this, what I'm showing you right here, is what I'm expecting to see on your homework. All right, I got one more example I want to run through with you. I would suggest you pause the video, try it on your own, and see what you get. I'm going to run through this one a little bit faster now. So pause the video and try it on your own first. All right, so the amplitude, you should end up getting 2. Absolute value of 2 is 2. Next up, for the period, you're going to do 2 pi divided by 1/4, which is the same thing as 2 pi times 4, which will give you 8 pi. The vertical shift I'll do in red. Vertical shift is your number outside. That's a -4, which will go down 4. And again, you can label that if you want to. last one, which will be my final graph, is your phase shift, which will be a minus 2 pi. Okay, it's a plus 2 pi here, so it'll be a minus 2 pi in the work. Okay, so first up, amplitude is 2. What that means is that my y values will now be going from 2 down to negative 2. Okay, so that's supposed to be a 0. So this stretches the whole graph out. It does not flip it. There's no negative there. So instead of going from 1 to negative 1, it's going to be 2 to negative 2. So multiply all your y values by 2. So 0 times 2 is 0. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And 0 times 2 is 0. Again, I'm taking these values here. 0 times 2, 1 times 2, 0 times 2, negative 1 times 2, and 0 times. So I'm working with the previous graph, just like we've always been doing. So here is our new graph. And again, we got it stretched out in the y direction. All right. So f of x is equal to 2 sine x. All right, now I am going to take all of the x coordinates. And again, I'm not going to do all of these because we've done a lot of these and I want you to be able to do this. Instead of dividing by 1/4, again, we're going to multiply by the reciprocal. So think about it. What's the reciprocal of 1/4? What do we get when we flip 1/4? Well, we get 4 over 1. So we're going to take this 0 times 4 over 1, which is just 4, which is just going to give me 0. All right, so let's do our first part here. Still 2 to negative 2. Okay, that's from the last graph. That's not changing. So the first point is 0. Next point, pi over 2. I'll do one more of these. Times 4. What does this give you? Hopefully you said 2 pi. So 2 pi. The next one, you're going to have pi times 4. Pi times 4 is 4 pi. We have a pattern here. What is it? It's going up by 2 pi every time. So 2 pi, 4 pi. Next up, 6 pi. And then the last one should be the period, which is 8 pi, which we got. All right, so this is my green graph. And 0 got moved to 0. Pi over 2 got moved to 2 pi. Pi got moved to 4 pi. 3 pi over 2 got moved to 6 pi. And 2 pi got moved to 8 pi. So you can see that this stretched the graph way out. Okay, so it got stretched out a lot. So f of x is equal to 2 sine 1/4 x. Okay, up next is the vertical shift, minus 4. So what this means is I'm going to take all of my y values and subtract 4. So my top point at 2, minus 4 gets me down to negative 2. 0 minus 4 gets me down to negative 4. And then negative 2 minus 4 gets me down to negative 6. Okay, so my new graph, let me extend this down here. My new graph is going to look like this. Y-axis is way up here. First one's going to be at negative 2. 0 minus 4 is negative 4. And negative 2 minus 4 is negative 6. All right, so I still have my points 0, 2 pi, 4 pi, 6 pi, and 8 pi. And again, I'm going through these quick now because I wanted you to pause the video and try it. So hopefully you did that, okay? And if not, you're going to have to pause and rewind and, make sure you understand where these values are coming from. But yeah, so anyway, looking at our previous graph over here, 0 minus 4 is down at negative 4. Next, 2 minus 4 is down at negative 2. Just keep going. 0, 4 pi 0 minus 4 gets me down to negative 4. 6 pi negative 2, well, negative 2 minus 4 is negative 6. And then 8 pi was at 0, minus 4 is down at negative 4. So there is our phase shift. F of x is equal to 2 sine 1 over 4x minus 4. Okay, one more graph we got to do here, and that is the phase shift. And there's a reason why I save it for last, and that's mainly because it's the most challenging. And if we save it for last, at least maybe we can build up some confidence on the first 3 steps. So here we go. I'm going to put my 5 points down. 1, 2, 3, 4, 5. And once I know where the y-axis is, I'll fill it in. So let's look. We're taking each of these x coordinates and subtracting 2 pi. So we're going to do minus 2 pi. Now this one actually worked out pretty nice, okay? So I'm not going to list all of these again. I'm just going to start off with some of them. So 0 minus 2 pi, that gives me negative 2 pi. So that's my first point, negative 2 pi. Actually, I want to put that up above because I know my whole graph is down below here. So I'm going to put this up here, negative 2 pi. Next up, the next point is 2 pi. Well, 2 pi minus 2 pi, that's nice because that's just 0. So this is 0. Well, what happens at 0? Yep, y-axis. Next up, 4 pi. Well, 4 pi minus 2 pi, that just gives me 2 pi. So here's my 2 pi. And then next up, we have 4 pi and then 6 pi. The y values are still the same. So negative 2, negative 4, and negative 6. So this point at 0 was moved to negative 2 pi. So 0, negative 4 is now negative 2 pi, negative 4. 2 pi got moved to 0. So 2 pi, negative 2 gets moved to 0, negative 2. 2 pi was at, 4 pi was at negative 4. So now 2 pi, negative 4. 6 pi got moved over to 4 pi, so that's down at negative 6. And then 8 pi gets moved to 6 pi, so that's at negative 4. So here is your final graph for this function. And again, this is f of x is equal to 2 sine 1/4 parenthesis x plus 2 pi, 2 parentheses minus 4. Final graph there. All right, so again, pause, rewind the video, watch it as many times as you need to make sure you understand this. Try to do it on your calculator so you can use that tool to help you get all of these x coordinates correct. I think the y coordinates won't be an issue. It's mainly just the x coordinates that are a problem with the period and the phase shift. So, but like always, if you have any questions, send me an email and let me know. Otherwise, you got 2 problems for homework, so not too much work to do there, but try those 2 problems and make sure you have all your work down. Make sure you have all your x coordinates, y coordinates, everything like that. Just make sure you have all the work down so you can get credit for it. And let me know if you have any questions.